to talk about more space stuff. I feel like most of my videos lately have been more so vlogs because there's so much going on right now in New York City. There's New York Fashion Week. There's so many different designers that are taking on like a whole astronomy inspired like take on a lot of their designs in some of their collections. It's really, really exciting. And World Science Festival is coming up. Like I think World Science Fair is actually next weekend, and there's just so much going on. But yesterday was the 40th anniversary of the Voyager mission for Voyager 1. So the Voyager missions there are two different spacecrafts, and one was Voyager 1. It was launched yesterday, 40 years ago, and then the second Voyager mission was launched then 16 days later. So Voyager 1 just crossed what's known as the heliosphere, and I'm going to get into that in a second. And then Voyager 2 is actually still within us. It's not yet in interstellar space, so it's still within the area of our heliosphere and our solar system. So like I said, I'll explain it in a little bit. But I kind of wanted to first break down some information that I wrote down for you guys. So I recently just started researching a whole bunch of really interesting stuff because I was looking at the archive on NASA's images on their website of all their different images of the sun that they've been taking from their SDO, Solar Dynamics Observatory. And so it was a spacecraft that was launched in 2010, and they take lots of images of the sun and they collect lots of information. They have a spectrometer on it, lots of really cool stuff. EVE stands for Extreme Ultraviolet Variable Experiment, which is a type of equipment that is on the SDO, so the Solar Dynamics Observatory, that collects a lot of this data and a lot of this information. So I wanted to get out first to kind of explaining what exactly this information is. So let's say that this is the sun. So the sun has a lot of stuff going on it because it literally is a ball of like just burning like gas and elements, and there's something called nuclear fusion going on inside of it, which is elements being converted into other elements through very high temperatures. So once it reaches over like 10 million degrees Kelvin, hydrogen atoms will start to be compressed together. When you have like 4 hydrogen atoms, they get compressed together, they get turned into deuterium. When you have 2 deuterium atoms and you get 1 hydrogen atom, those get turned and converted into helium. And it's just this constant process of atoms fusing and elements fusing into new elements, which is really cool. And it's under like certain amounts of pressure and temperature, like I said, that 10 million degrees Kelvin. So through this, because it's literally like a ball of just craziness, it's also plasma, you have certain areas where there's like storms, solar storms, which are like sunspots. So sunspots are darker regions that are actually the cooler regions, and these regions start to form because of this crazy activity going on within the sun, and the actual like change in pressure in some areas, a change in electromagnetic energy in some areas, that storms will start to happen, and they'll actually be a lot cooler. But sometimes these regions can explode, and what will come out of it would be either solar flares, so that'll be like whee, or coronal mass ejection. Well, coronal mass ejection is actually like over here, but we like solar flares. So solar flares are highly charged energy particles. So it's just lots of energy, lots of like just stuff that comes out of the sun. And then you have these coronal mass ejections that are physical matter that explode from the corona, and it literally is like actual physical pieces of matter. It's like plasma shooting out. And so what happens also is because the sun is spinning so quickly, you have like wind. It's constantly blowing wind in whatever direction it's blowing. So if say like Earth is down here, say this is Earth. Let's see if you can see that. I'll bring this up higher. Let's say that's Earth. A lot of times a solar flare or coronal mass ejection or even solar activity, solar wind, it's going to affect space. So it's very important for us to keep track of that because it could, be damaging to like our satellites that orbit Earth, which would be like around here, which would mess with our communications. It could be bad for like astronauts. It also can be harmful for like communications with like airlines and planes, and even like our apps on our phone. I mean, the only reason that we have internet is because literally like our cell phone is sending like, you know, actual signals up to like a satellite that's sending signals back on Earth, and it's just it's crazy. So yeah, so that's like what solar activity pretty much is. So now with this, like, you know, the reason why the Solar Dynamic Observatory is so important is because we need to keep track of just how much activity is coming to us from the sun, how much activity there just generally is just happening in space. And so what's really cool is there's something called a diode, and a diode is a piece of equipment. A diode, it's on the spacecraft, on the Solar Dynamic Observatory. So a diode be like this. So this part could actually receive like just how bright one of those solar flares will actually be. And then you have like a dark diode. And so a dark diode, it's still just the same piece of equipment, but it literally is like blocked. Let's just say that this is like a shield, right? This way, when it's blocked, it's still receiving, you know, like when a solar wind or a solar flare comes in, this diode is receiving like the brightness of it. And this one, it's blocking the brightness, and this way it can just focus on how much energy is actually being retrieved from this solar flare. Because a lot of times, the brightness can't interfere with the calculations of the actual energy that's received from the solar flare. And this is very important because, you know, sometimes something might look like super bright, but, you know, there might not be as much like energy particles being received from it. And this is important because it's really important to know, like, okay, if one of our spacecraft are orbiting right when a solar flare like is going off, like, okay, we're gonna have to like plan how to figure this out and make sure it doesn't get harmed. Okay, so this is going to bring me to the heliosphere that I first mentioned. Right, here's the sun, okay? And I'm gonna just use blue, because you could see that easily, to represent our solar system.
So it's going to be, let's do this, so it's going to be Mercury, Venus, the Earth, this is not to scale, don't judge me, Mars, Jupiter, Saturn, Uranus, and Neptune. Okay, so let's say this is
going to be our solar system, right? So, you have like the Voyager spacecraft. Let's say that it's pink. So let's say that this is Earth, this is the Voyager spacecraft. So the Voyager spacecraft for Voyager 1, we'll say, is like right here. And again, this is not to scale. And what just we announced recently was that the Voyager 1 spacecraft had just left what's known as the heliosphere, and it is now floating in interstellar space. And it has like the golden record, which has like some songs, it has like some sounds of like water and animals, and it has like voices talking, and it has all these really cool musics and all this fun stuff. And so that's being transmitted through radio waves out into interstellar space. And also it has directions of how to get to Earth pretty much, which is pretty cool. So what exactly is the heliosphere? So the heliosphere, I'm going to use green to represent this. The heliosphere is like a bubble of space that's with, like, you know, that actually is within our solar system. Bubble of space in which the charged particles from the sun has reached. So there's like a certain limit in which like all the highly charged particles from the solar activity that's being emitted out into space, there's a certain area that it can only reach. So it can't reach anything further than that. So it literally is like a bubble of space that has these like magnetic charged particles from our sun. So it literally is like just a heliosphere, and helio stands for sun, and sphere is like a three-dimensional circular object. And so this literally is a ball in space that has these electrically charged particles. So from, you know, magnetic charged particles from solar winds and whatnot. And so what's really cool is that, you know, now you still have, so Voyager 1 just left it, and you have like Voyager 2 that's so close. Voyager 2, it's like just on the cusp right now, and it's like soon going to be heading right outside this heliosphere. So yeah, so I kind of just want to talk with you guys about that. There was a really cool diagram that I've been trying to dissect for the past 2 days, of like just the actual data that's collected from these diodes, like reteaching myself a lot of things right now. But so, you know, as a lot of you guys do know, I was conducting research in astrophysics. I was an astrophysics major for about 3 years. I studied protoplanetary disks, which are brand new, hopefully one day planetary systems found in the Orion Nebula around newborn stars, so an accretion disk that starts to form around newborn stars. And then I started doing research on brown dwarfs, more specifically M dwarfs, which was really pretty cool. And that was at the Hayden Planetarium under the NASA Space Grant, National Science Foundation, the American Museum of Natural History Research Facility, and then eventually the CUNY CSIP program. And it was amazing, but in the midst of that, I got scouted for modeling in New York, and I was like, oh, okay, well, I still want to be a researcher, I want to do astrophysics, but then I've always loved the creative arts, and I always wanted to pursue that, and I've always been a dancer, and so I was like, how do I do both? So I started to do both, and then actually put my research and my schooling on pause to continue and pursue the arts and pursue acting full-time, and continued up with my dance training at Broadway Dance Center and did a stand-in for the Rockettes, and it was really cool, and wanted to come back into my root of astrophysics and wanting to relearn everything about, you know, just aerospace engineering and then everything that has to do with physics. And so I actually just started up some courses, which are pretty cool, through Stanford University Online. I'm very excited to announce that, and I'm going to be doing that, so I'm very excited, and still pursuing everything that I'm doing. I just booked a role on Blue Bloods. I'm very excited. And I shot the cover for Psychology Today magazine that actually comes out, I think it's in October. So yeah, anyway, but yeah, so anyways, I just kind of wanted to talk about that with you guys, and I'm like relearning everything. Like here I have like irradiance, which is, you know, the radiation that comes from the entire sun. It's through, you know, milliwatts, and 1 watt is like 1,000 milliwatts. So like you have a 40 watt light bulb, then you'd have 4,000 milliwatts. And the wavelengths in which we are actually retrieving from the sun, from the solar activity, those obviously are measured through, you know, nanometers or meters, and what was actually absorbed was it was like the heat flux. So what that means is it's just the change in heat that was being received over like a 3-day period. So it was a 3-day plot that I was looking at. I'll actually share it with you guys after this. And yeah, I just found it to be really, really interesting, and relearning everything about like the light spectrum and gamma rays versus X-rays, and like why we're able to use X-rays in certain things, and like why radio waves are the things that we use to transmit signals out into space, and you know, and even like how I can turn my radio on and listen to music. It's just literally the way in which the sound is being traveled through actual physical oxygen and matter and time, and it's able to vibrate. It's the coolest thing ever. So anyway, I hope you guys liked this video just about the Voyager missions, and yeah, about solar activity and whatnot. So yeah, leave a comment if you guys want a video different, I don't know, on something else or whatever it is. I'm going to be doing a course right now. I just started on Einstein's theory of special relativity, so that's going to be really cool. I'm very excited for it. It's going to be it's going to be kind of like a history class combined with the physics behind his theory. So I'm very excited for that, and yeah, let me know what you guys would want me to talk about next. And soon I'm actually heading to a job for Refinery 29. I'm very excited for that. Woo! And it's the end of the US Open, and it's also New York Fashion Week. So I'll talk with you guys soon, and I hope you like this video. Thank you for watching. Thank you so much. Talk with you guys soon. Bye!